so that we have it. All right, so today we're going to add, subtract, and factor linear expressions. Okay, expressions with rational coefficients. So we are going to identify problems that require me to add, subtract, factor, and expand linear expressions with rational coefficients. All right, so we're going to talk about a few vocabulary words first. So we wrote expressions the other day. So for example, if we had 4x plus 5, that was an expression. Okay? So in an expression, we have several things. So a number with a letter is called a coefficient. Okay? So that kind of takes care of that word right here, coefficient. So anything with a letter is considered a coefficient. And of course, we know that a letter is a variable. And any number by itself is called a constant. Okay? So we will kind of use those words interchangeably when we start talking about expressions combining like terms and equations. All right, so we are looking at the figure over here, the hexagon. And the hexagon, one of its side lengths is 5x plus 2. So we want to know, write an expression that represents the total length of the trim on the hexagon. So we want to know what is the total all array around. Okay? Anybody know how we would set that up?
Can I take a guess?
Sure, absolutely.
I have no idea what I'm doing, but like, okay. Maybe you could like add the 5 plus the 2 to get 7x. And then, hold on.
So think about what we did yesterday, Reagan. Did we add anything that had a variable with a number that didn't have a variable? Didn't we combine terms yesterday? I thought we did. Maybe not.
I can't remember.
Yeah, we combined like terms yesterday. So yesterday, let me see if I can find that. Yeah, it was 7 point, I know what lesson it was. Yeah, so yesterday, remember, here was the check understanding, right? And we had 5x and we had 3x to get 8x. And then we had j plus 0.5j to get 1.5j. So that was the check understanding. And then here was the on your own. So yesterday, we only added things that had a variable. So here we added 40x and 15x to get 55x, but we didn't add the constant to something that doesn't have a variable. Okay? So hopefully that helps. So I can't add the 5x and the 2 because the 2 doesn't have a variable.
To divide or something.
Okay. We're not trying to find, okay, so if we divide, that would kind of give us like the unit or the side. So if I had the total of the sides, I would divide because then that would give me one side.
Oh, so we're supposed to find the length. Like if you combine all sides, like the perimeter kind of?
Yes, yes.
Okay.
So perimeter. We want to find the perimeter.
Okay. That makes it much easier.
So what are we going to do?
So I just think we would put them in parentheses, and since it's a hexagon,
Yes.
Times 6.
Yep. So that's one way to do it. The other way is I could do 5x plus 2 plus 5x plus 2 plus 5x plus 2 plus 5x plus 2. I could do that 6 times, right? Is that the most
Wait,
effective
are we not
way to do
solving
it?
it?
We
Wait,
will.
I'm
Yes.
confused.
Yes, we are going to solve it. But I just want you to understand that this is also equivalent to this.
Oh.
So 1, 2, 3, 4, 5, 6. Is this?
Couldn't you also use an exponent?
No. Because an exponent does something completely different. So if I did that to the 6th power, that would be like 2 to the 6, which would be 2 times 2 times 2 times 2 times 2. I'm not multiplying my, I'm not multiplying my 2's, I'm adding them. So good thought though. Good thought. So this is not the most effective way to do it, but it is equivalent, right? So let's go back to this way, which is the effective way, which is the distributive property. So the distributive property says that whatever is on the outside, I'm going to multiply by everything on the inside. So I would get 6 times 5x plus 6 times 2. And that would give me 6 times 5, which is
So if
30x, because the x comes along for the ride, and then plus 6 times 2, which is 12. So this is equivalent to this.
So you can multiply a coefficient by a constant.
Yes. Yes. But I can't add. So I can't add a coefficient to a constant, but I can multiply. Yep.
Okay.
Good question, Xander. Very good question. Okay? Questions on that part? All right, so the turn and talk is pretty easy. The turn and talk says which is a like term with 5x. 10x, 5y, or 5?
5y.
X.
I feel like it'd be 5y.
I think of 10x because
I say 5y because whatever you use as a variable doesn't matter.
yes, that's true.
So
I just think 10.
So Xander was right. It is 10x, and
10 is so
right. So 10 has nothing to do with it. What has to do with it is this right here. Okay? So when we are adding, the variable does matter. If we were multiplying, then I can multiply x times y and get xy. Okay? But when we are adding, variables matter. Okay? So let's write that down. When we are adding, we have to, and I know that's not proper English, but I don't know how we would write it. When we are adding, we need, let's put need, I like that better. The same variable in order to add. Okay, so they have to be the same. They don't have to be the same number, but it has to be the same variable. All right, so let's look at number 1. And guys, we're going to kind of, as we go through this, we're going to go a little bit off script, and we may not fill in every single box just because I don't like the way that they do this particular lesson, okay? They make it a little bit harder than what it's supposed to be. All right, so we have a yard that's shaped like an irregular quadrilateral with the side lengths shown. So 2y plus 4, 4y plus 1, 1/2 plus 6, 3y minus 2. Okay? We want to find the perimeter. Okay? So it says write an expression that shows the perimeter of the yards as a sum of the length of the sides. So it doesn't matter where I start. So I'm going to start here. So 3y minus 2 plus 2y plus 4 plus 4y plus 1 plus 1/2 y plus 6. Okay? I'm not going to worry about b. So now it says we're going to use the properties and we're going to rearrange to get all of our like terms together. Okay? So does it matter if I put my constants first and my coefficients? It doesn't matter. Okay? But I'm going to put my coefficients and variables first. So 3y plus 2y plus 4y plus 1/2 y plus -2 plus 4 plus 1 plus 6. All right? Then it says, can you identify the like terms? Well, yes. The y's are all alike, and all the constants. So all of these are all alike. So now we're going to combine our like terms. So 3 plus 2 is 5, plus 4 is 9, plus 1/2 is 9 1/2. So really, guys, once you've grouped everything that's alike, you're really only adding the coefficients. And then the variable just kind of comes along for the ride. Okay? And then here we have -2 and 4, so that gives me 2 plus 1 plus 6. So that would give me 9. All right? So then F says, show how you use the distributive property to combine the y terms. Well, I really didn't use the distributive property, but I'll show you what they're asking you to do. So remember we talked about multiplication and division problems being factors. So what we are going to do is we're going to factor out what is in common. So every single one of these has a y in common. So I'm going to factor that out. And then what is left is basically just my coefficients. And then we still end up with 9 1/2 y. Because if I did it backwards, right, if I distributed, y times 3 is 3y, y times 2 is 2y, y times 4 is 4y, and y times 1/2 is 1/2. So I just wanted you to see that this and this, as well as, are all equivalent. So when they ask you to write it in a different way, you could have written it either one of these 3 ways, and it's considered to be equivalent. Any questions on that one? No? All right.
Good.
Go ahead, Xander.
No, I just said I think we're good.
Okay. All right. So that's what the turn and talk talks about. It says, explain why you might want to combine like terms before evaluating the expression. Discuss why the expressions in part A and part E look different. So if we go back to A, right, that was that long expanded process. But if I look at E, E is a lot shorter. So why does it look different? What did we do?
You combine like terms.
Yeah, I combined like terms. Okay? And we're going to use, when we get into solving equations, we're going to use this combining like terms a lot. Okay? All right. So moving on to number 2. All right, so we're not going to fill in all of these boxes because I just don't like them. All right, so we have an equilateral triangle, and we're trying to find the perimeter. So think about what we did on the very first problem. All of these are the same, right, because it is an equilateral. So what could we do to find the perimeter?
Multiply by 3.
Yep. So multiply 7.2D minus 4 times 3. And that's really what C is kind of asking. So 3 times 7.2D minus 4. If you wanted to write it in expanded, you could. But that definitely is not the most effective way to do it, is it? So that's why I said we're going to kind of go off script. Go ahead, Reagan.
I have a question about the books.
Okay.
Why do they want to try to explain it in the most difficult ways?
I don't know. So that's why we're kind of going off script a little bit, because I'm trying to make it easier for you guys to understand. Okay? All right. So it is the distributive property, right? So we're just going to rewrite it here. And now we're going to distribute. So 3 times 7.2D. And then 3 times negative 4. So what is 3 times 7.2D? So that would give me 6, right?
21.
So 21.6 what? What comes?
D.
Yep, the D comes along for the ride.
Plus, is it negative 12?
Yep. Okay, so I could also have 21.6D minus 12. So remember, this and this are equivalent. So either way would be marked right. Okay? All right, we're not going to worry about the turn and talk because we didn't do B. Okay? All right, so now this is like what you were doing, Xander, at the beginning. You thought we had the total and we were trying to find the sides. So on 3, we have the total. Now we're trying to find what each side is. So what would I need to do? So if the perimeter is 20x plus 8, how am I going to find one side of the square?
Wait, would it be like...
Now divide.
Yep. Now divide. So 20x plus 8. How many sides are in a square?
4, of course.
4. So 20 divided by 4.
That's
5.
5.
Yep, and the x comes along for the ride. And 8 divided by 4 is?
2.
Yep. So each side is 5x plus 2.
This square looks a little.
This one was kind of easy, not gonna lie.
That's why I said if we go off script and don't fill in everything, it's a lot easier to understand. Okay? All right, we're not going to worry about those because we already did it. All right, let's look at this. And once again, we're not going to fill in these boxes. So ignore the boxes. Okay? All right, so we're going to combine like terms. So which terms are alike?
Negative 2t
And negative t.
Okay, so I'm going to separate those. Negative 2t plus negative t. And what does that give me? What's in front of here?
1.
Imaginary 1, right?
2t. No, wait, no, I'm dumb. Negative 1t.
Negative 3t, right?
Oh, negative.
Why negative 3t, Xander?
Because they're both negative.
Yep, because they're both negative. So you owe me 2, you borrow another $1, so you owe me 3. All right? So now what else is alike?
The constants.
Yep.
Yeah, the constants.
Okay, so that would be
5 and 3.
negative 5, right?
So negative 5 plus positive 3.
So what does that give me?
Negative 2.
Yep.
What?
All right,
Yeah.
so put it together.
T.
So that would be my answer. Negative 3t minus 2. Oh, Reagan got kicked out. Okay, or we could do negative 3t plus negative 2. Okay, so either one of those would be correct. Okay? All right, so we're not worrying about none of this here. All right, look at B. This one's a little tricky. What does this mean right there?
Subtract.
Right. So I'm going to subtract whatever is in here from what is here. Okay, so let's think about that. So I have 3D, but I'm going to subtract 5D. Right? Because that's what that means. And then I have 7, and I'm going to subtract a negative 5. So what do I get? What can I do here?
Wait.
Could I change it to... Yeah, could I...
Hold on.
So remember, if we have a subtraction, I can add the opposite, right? So what does that give me? You owe me 5. You said, here, Miss Lavelle, here's 3. What do you owe me?
2.
Yep. All right. What did we say when we have... I don't know. Somebody's not on mute. What happens if we have a double negative? What does that mean?
You get a positive.
Yeah. So this is really 7 plus 5. And 7 plus 5 is?
12.
Yes. Thank you, Tyrone. So my answer would be negative 2D plus 12.
I think what's throwing me off is I'm used to like having an answer. I'm not used to having expressions as my answer.
Yep. Yep.
It's just like throwing me off.
Yep. We're not solving yet, and we're not evaluating. So we're not putting what D is yet. Right now we're just trying to figure out what are the expressions. All right. So then ignore all that. All right. So now this one's kind of like the square problem, right? Ignore this. So this is the square problem. And I want to figure out what each side is. So we need to figure out, sorry, my light went off. We need to figure out how many sides we have. So greatest common factor. So a number that I can divide into 30 and 5, and it has to be the same number. So what would that be? Kind of tells you down below. It tells you what it is, right? So 5 can divide into that. So that's my factor. And then what is left is 6x minus 1. Okay, so we're going to write that. The factor goes outside. And then what each side is goes inside. Okay, does that make sense? So when it says greatest common factor, you're finding a number that divides into both of them, and it has to be the greatest number. All right. What about D? What do we do on D? This is the distributive property. So what do we do? Negative 7 times what?
3x.
Yep. And then?
Plus negative 7
times 1.
Yep. All right, what does that give me?
Negative 7 times 3x is negative 21x, I believe.
Yep.
And then negative 7 times 1 is negative 1, or negative 7.
Yep. So that is your answer. Okay. All right, so that brings us to the check understanding. Okay. I want you guys to spend a few minutes trying to do it, and then we will check it before you leave. And then tomorrow, guys, I know that the On Your Own is a little bit long. It's 2 pages, but I feel that we need to practice with all 2 of them, with all the both pages. Okay, so we can get that practice in of combining like terms. All right, so take about 5 minutes to work on this, and then we'll go over it before you guys leave today. Okay? No, I can't get it to stay. See if I can get it to stay this way. All right, there you go, for those of you that can't see it. No, Jameer, we're not going to do the On Your Own today. We're going to do the On Your Own tomorrow. I just did a quick look at the On Your Own. Greatest common factor. That's what we just did right here. So we find a number that divides into both of them. Greatest common factor. That's what that is. Anybody want to try number 2? All right, so we distribute 3 times 3x plus 3 times 6. So 3 times 3 is 9. The x comes along for the ride, and 3 times 6 is 18. All right, GCF. So a number that will divide into 24 and 20. And it has to be the greatest. So I know 2 will go, but that's not the greatest. 4 would be the greatest. So 4 times 6 is 24, and 4 times 5 is 20. So that would be the answer. All right, and then this one, we're going to distribute. So 4 times 3 over 2f plus 4 times 1 minus 7 times f plus negative 7 times 5. So now we got to multiply. 4 times 3, so 12 over 2f, which is 6f, plus 4 times 1 is 4, minus 7 times f is 7f, plus negative 7 times 5 is negative 35. So now we got to combine my terms. So 6f minus 7f and 4 plus a negative 35. And I can actually make this plus a negative 7 if I wanted to. So once again, you owe me 7. You say, Miss Lavelle, here's 6. What do you owe me?
1.
Yep, you owe me 1. So negative, I don't have to put the 1 there. I can just say negative f. And then once again, you owe me 35. You say, Miss Lavelle, here's 4. What do you still owe me?
$31.
Yep. So that would be that answer. Okay?
Yep.
All right. So you are more than welcome. You have about 5-6 minutes. If you want to get started on your own, you are more than welcome to do that. Or you are more than welcome to wait till tomorrow. But I will be here until 4:15. So completely up to you. So if you want to log out, log out. If you want to work, I'll be here.
I'm gonna go by Miss Lavelle.
Yeah,
Okay.
I'm gonna go.
All right. See y'all tomorrow. Okay, I'll fix it. I saw your message. Let me mark Rebecca absent and no Fox, right? Let me see. I thought I put it on Seesaw, but I guess I did not. Seesaw. You are correct. All right, give me 1 second and I will add it to Seesaw. All right, it should be there. Try to refresh.